Did you know that the concept of nanotechnology was first introduced in a talk titled "There's Plenty of Room at the Bottom" by the renowned physicist Richard Feynman in 1959? He proposed the idea of manipulating individual atoms and molecules, a concept that seemed like science fiction at the time. Yet here we are in the 21st century, where nanotechnology is not just a reality, but an integral part of our lives. Now, let's dive into the fascinating world of nanotechnology and its evolution over the years. The history of nanotechnology is typically divided into 4 generations. The first generation, from the 1980s to the early 2000s, was all about passive nanostructures. Scientists were primarily focused on learning how to produce nanoparticles and nanostructures, and their applications were largely limited to coatings, nanoparticle-based paints, and sunscreens. The second generation, spanning the early 2000s to around 2010, saw the rise of active nanostructures. This era was marked by the advent of nanodevices and nanoelectronics that could change their state during operation. This brought about significant advancements in fields like medicine, where targeted drug delivery became possible, and in electronics, where memory storage saw a massive boost. Then came the third generation, from around 2010 to the present, which is all about systems of nanosystems. This era is marked by the integration of nanoscale devices into functional systems, leading to the development of more complex structures such as nanorobots and nanonetworks. The fourth generation, which we are just beginning to explore, aims to achieve hierarchical nanosystems with molecular nanosystems. This involves creating systems where each component has a specific task, and all these tasks are coordinated, similar to how biological systems function. As we compare these eras, it's evident that each new generation doesn't replace the previous one. Instead, it builds upon it. The focus has shifted from creating simple nanostructures to developing complex nanosystems, but the basic principles and techniques developed in the earlier eras are still in use today. Nanotechnology has a myriad of applications across various fields. It's revolutionizing medicine, electronics, energy, and even environmental science. From creating more efficient solar panels to developing targeted cancer treatments, the possibilities are endless. However, along with its potential, nanotechnology also brings its own set of challenges. There are ethical and safety concerns that need to be addressed, and more research is required to understand the long-term effects of nanomaterials on our health and the environment. So, the journey of exploring the nano world is far from over. There's still a lot to learn, a lot to discover. It's an exciting field that's constantly evolving, and there's no better time than now to delve into it. Whether you're a researcher, a student, or just someone with a curious mind, nanotechnology has something to offer you. It's a field that's shaping our future, and understanding it can give us a glimpse into what that future might look like. So go ahead, explore the world of nanotechnology. Who knows, you might just find that it's the key to solving some of the biggest challenges we face today. Remember, as Richard Feynman said, there's plenty of room at the bottom.